This is Origin Stories, the Leakey Foundation podcast. I'm Meredith Johnson. This is the sound of the forest in the foothills of the Altai Mountains in Siberia, outside of a place called Denisova Cave. And I can imagine what it was like here, back in the Pleistocene. If you stood in the opening of the cave and looked out, you would see a beautiful view. A sparkling river flows not far below. If you look to the left, you would see a valley which opens up to the steppe that goes more or less uninterrupted all the way to what is now Mongolia and northern China on one side and to Central Europe on the other. Vast herds of migratory animals like bison and horses moved through the valley. Fish swam in the river, and the lush green forest spread out all around. Some of the prehistoric people who lived in the Altai Mountains came to be known as the Denisovans, and the story of their discovery and what it means is the topic of our episode today. This is a recording from inside Denisova Cave. It was taken in 2011 during a conference. Russian scientists are telling their visitors about something amazing they discovered in Denisova Cave one summer day. It was an insignificant-looking little scrap of a fossil, a tiny fragment of bone from the tip of a child's pinky finger. It was about as big as a thin slice of a jelly bean, but hidden inside that little fragment was a secret history of humankind.
Well, there are a few questions that are really basic for the human existence, and where do I come from is probably one of the most important ones, after like, what am I going to eat tonight? Where do I come from is something that people have been asking for a very, very long time. I'm sure, Neanderthals wondered about it sometimes as well. Like, why are we here? It's a very important question. The other reason for it, I think, is though because it matters for our lives today.
That's Bence Viola. He's a paleoanthropologist at the University of Toronto and a Leakey Foundation grantee. He's part of the international team studying the fossils from Denisova Cave. And for a large percentage of people in the world today, those fossils are part of the answer to the question, where do I come from?
Denisova Cave has been excavated since the 1980s by my Russian colleagues. And they actually, in the 80s already, they found two teeth that they assigned to hominins.
These teeth were first described in 1988 by a dental anthropologist named Christy Turner.
And he proposed that these two teeth are Neanderthals. And this was interesting because at the time, nobody had a clue that Neanderthals lived this far east.
When Viola was working on his PhD dissertation, he examined those teeth from Denisova Cave and came to a different conclusion than Turner did.
In my opinion, the two teeth were actually neither Neanderthals nor modern humans, especially one of them seemed just very strange.
Viola found that the tooth that didn't seem human or Neanderthal actually turned out to be a worn-down bison tooth, and that's what it says in his thesis. After that, Viola got a postdoctoral position with Svante Pääbo and his group at the Max Planck Institute, and he soon had another chance to study fossils from Denisova Cave. The little sliver of pinky bone from Denisova arrived to Svante Pääbo's lab not long before Viola did. The Russian scientists had packed it up and sent it there to see if Pääbo's team could get any ancient DNA from it. Because at the time, Pääbo was working on sequencing a complete Neanderthal genome. Viola, meanwhile, had just moved into his apartment in Leipzig, Germany, and set up his internet.
And the first email I got was from Svante saying, Bence, you have to come to the Institute immediately. You have some very interesting things to discuss with you.
Pääbo's team had successfully extracted DNA from the tiny bone.
And it came out as neither a modern human nor a Neanderthal, a completely different population. I was thinking back to my PhD and, like I said, in Denisova, there's something that's neither a modern human nor Neanderthal. But this finger bone later on proved me right.
At first, they were only able to extract mitochondrial DNA, a type of DNA that's inherited from the mother, which only has about 16,500 base pairs. But you can learn a lot from it. For instance, you can use it to establish sort of a molecular clock, and you can get an idea of when the last common ancestors of modern humans and this population lived.
And based on the mitochondrial DNA, it looked like it was 1.5 to 1 million years ago, which was mind-blowing. When you have something here that's maybe 50,000 years old, but it has the last common ancestor with modern humans more than 1 million years ago. And so 2 weeks or 3 weeks later, we flew off to Siberia because we felt like this is not something we can discuss with our Russian colleagues by email. It was so surprising, the result. And so we said, we're going to come and we need to talk to you. And we flew there and we showed them our results, and they were completely amazed, of course.
And it was truly amazing because that tiny bone was evidence of a previously unknown kind of prehistoric human. And it was the first time such evidence came from DNA. Viola's Russian colleagues had a surprise for him, too.
And then they pulled out a tooth from their pocket that I haven't seen before. I thought I've seen all the human remains from Denisova cave, but there was this beautiful, gigantic molar. And seeing that, I was like, oh, this is not a Neanderthal nor a modern human. This is clearly, the DNA is right. This is something different. And that is Denisova 4, which is the large Denisovan molar that we described soon after.
Denisova 4 is a very large upper molar with a surface area twice as big as a modern human molar.
So it was really just an amazing story. We found this population based on a fossil, this fragment of a finger bone, which, morphologically, you could probably tell it's a hominoid. But I'm not even sure you could exclude that it's chimpanzee. It's such a tiny fragment. And from its DNA, we could tell not only when its last common ancestor with modern humans lived, but later on we could also extract nuclear DNA, and we could show that, these population, the Denisovans, were actually a sister group of Neanderthals, so more or less like the Asian cousins of Neanderthals. And the geneticists could also show that modern humans actually interbred with this population because we see traces of Denisovan ancestry in Melanesian populations. And then later on now we also know that you even have it in Asian populations at much lower levels. So the Denisovan story really shows that even extremely minute fossils can give us incredible insights into our past.
The existence of the Denisovans was announced in 2010 in the journal Nature. Until just a few months ago, this new member of our human family was only known from that minute pinky bone fossil, a few molars, and a bit of bone so small it was hard to tell what part of the body it came from. The sum total of all the fossils the Denisovans left behind could easily fit in the palm of your hand. The ancient DNA inside those fossils, though, adds a fascinating new twist to our human story, and all from this one cave in the foothills of the Altai Mountains in Siberia. A cave that, thanks to its cold and stable environment, preserves DNA remarkably well. And I want to go back to the cave these fossils came from for a bit before we move on to the astounding insights they can give us. In January 2019, scientists published a timeline of life in Denisova Cave, a detailed study of the 103 layers of sediment and the tools, bones, and other artifacts from the cave. This timeline suggests that humans, Homo sapiens, Neanderthals, and Denisovans, occupied the Siberian shelter from around 300,000 years ago up until fairly recently.
The story is supposedly that there was a hermit in the I think in the late 18th century, Denis, who kind of withdrew there and moved into the cave, and people came and asked him for his wise judgment and ideas, and so it's named after him. But I also heard that this is in reality not really true. So this is Wikipedia says this, but my Russian colleagues, for example, disagree.
The story of Denis the wise hermit may or may not be true, but it is true. And there's evidence that people did live there up until a few hundred years ago. Complicating the picture are the animals that lived there. Bronze Age people kept herds of goat and sheep in the cave, something that's still done in Central Asia today. And when you keep animals, you accumulate poop and parasites and things like that.
And so what you do is, but once a year, you set it on fire and burn it out. So you have these like layer deposits, ash deposits. You have these very thin layers of dark gray and light gray on top of each other. It's really beautiful, but it's bad to breathe it in, of course, because it's all burnt goat and sheep poop.
Below those layers of goat and sheep poop are older Pleistocene layers made of cave loam. Those layers contain things like fossils, stone tools, beads and other ornaments, bones with cut marks, and other evidence of life in the cave.
We have now in total, I think, 14 or 15 hominin fragments from Denisova. And with the exception of one, all of them are smaller than 2 centimeters. They're smaller than an inch. So they're all either an isolated tooth or the finger bone. And we also have a bunch of fragments that are just random long bone fragments that were identified through a new approach using peptide fingerprinting, where you run mass spectroscopy on the collagen molecules that are in there.
Without all this new technology and these new methods, it would be nearly impossible to make sense of the bone fragments in this cave. Why are they so tiny? It's because of another animal that's lived in the cave from time to time.
The cave is full of hyenas. There's several layers where it seems to have served as a hyena den. But these hyenas, they eat the bones, and they usually either kind of throw them up, regurgitate them, or poop them out. And so likely these little bone fragments that we find were either regurgitated or pooped out by hyenas. So I think, and this explains why, all these fragments, each of them is a different individual. We don't have 2 fragments that come from the same individual. They're all from different individuals. Some from Neanderthals, some from Denisovans.
Viola says a lot of these individuals were children.
We don't know whether, the hyena just went and grabbed a kid from somewhere and took it away. They do that sometimes. Or whether they dug up dead bodies, which is a possibility as well. Hyenas are scavengers and opportunistic. And if they smell something good rotting, they might dig it up and bring it to their den for the babies. Which is, it's a bit of a weird picture, but some of the specimens we have, for example, are not only digested, but also have a lot of hyena DNA. And there's one finger bone, not the Denisova finger bone, but a Neanderthal finger bone that has a lot of hyena DNA in it. And I kind of imagine it like a hyena pacifier. You have this little hyena baby who sucks on a Neanderthal finger and at some point just spits it out. And then we find it 100,000 years later. Hyenas are weird.
Hyenas aside, it looks like different groups of prehistoric people took turns living in this prime cave real estate over and over again for millennia. The timeline of human life in Denisova Cave seems to read like this. The oldest signs of human life in the cave are simple stone tools, estimated to be more than 280,000 years old. The oldest sign of Denisovans is somewhere around 200,000 years ago, and again around 50,000 years ago. Within that date range, Denisovans likely occupied the cave several times, and there's also evidence of alternating Neanderthal occupations within that time frame. And we know they must have met up there at least once because of an astounding discovery announced in 2018 by Viviane Slon and colleagues.
So my name is Viviane Slon. I'm a postdoc at the Max Planck Institute for Evolutionary Anthropology in Leipzig in Germany, and I work on ancient DNA.
Slon was working with some of the small slivers of bone from Denisova Cave. Colleagues of hers in Oxford and Manchester had sorted through thousands of bone fragments, looking for collagen signatures that would tell them which of the bones belonged to hominins and which to other animals.
So the bone itself is very small. It's only 2.5 centimeters long, so just by looking at it, you would never know it's a human bone. It was really a story of persistence because this was the bone number 1,227 that they had to look at. So that's how the bone was identified at all as a hominin bone to begin with.
The British scientists sent this bit of bone to Slon in Leipzig, and she carefully drilled a few milligrams of bone powder from it and extracted some mitochondrial DNA, which confirmed it was indeed from a hominin.
That's when it was called officially Denisova 11, but among friends we call her Deni.
She sampled a bit more of the bone and was able to get some nice nuclear DNA, which she compared to that of Neanderthals and Denisovans.
So the first thing that we did was to look whether this individual was a Neanderthal or a Denisovan, because at Denisova Cave, we already knew that they were both groups that have previously been found. And usually what you see is that an individual matches either one or the other. But this wasn't the case for Deni. Denny was very special. And what we saw was that the DNA fragments from Denny actually matched both Neanderthal variants and Denisovan variants in approximately equal proportions. And that told us that she has both Neanderthal and Denisovan ancestry in almost equal proportions. And what we realized was that this person was the daughter of a Neanderthal and a Denisovan.
I asked her how she felt when she got those results.
At first, I was sure it was a lab error. We're very careful in the lab. We work in a clean room. We have very specific protocols on how to handle ancient specimens. But, mistakes can happen. It's not that it's completely unheard of. And I was sure that I made some kind of mistake, that there was some kind of mix-up, that two samples get mixed together or two DNA extracts get mixed together, something. I thought something went wrong. And so we repeated the experiment. I went back to the bone and extracted DNA again and did all the process again, a total of 6 times. And each and every time we got the same results. So at that point you say, okay, it must be real. And if it's real, it's really exciting.
Because it means what?
So this individual had one Neanderthal parent and one Denisovan parent, which would make it the first time that we see a daughter of 2 different archaic hominin groups. It's, of course, not the only explanation that could be, so we had to do further analysis to verify that there were not other potential scenarios that it could explain this. For example, if her parents came from a population that we hadn't sampled yet and where everyone has both Neanderthal and Denisovan ancestries. But we did some further tests and we confirmed that, in fact, what we're seeing is a first generation, so a daughter of a Neanderthal mother and a Denisovan father.
The odds of finding an individual like Denny are mind-bogglingly rare. And until recently, it wouldn't even have been possible to pry such an amazing story from such a small fossil. They estimate that Denny lived somewhere around 90 to 100,000 years ago. And Bence Viola was able to estimate that Denny was at least 13 years old when she died.
She could have been far older, but that's sort of the minimum age. And that's really interesting because it tells us that she survived past infanthood, past sort of young childhood. Somebody was caring for her, and I think that's very interesting.
Denny's story gives us some idea about the lives of the mysterious Denisovans. Thanks to her, we know that at least once a Denisovan man met and had a baby with a Neanderthal woman. Another exciting, recently announced discovery from Denisova Cave is a section of skull that gives us a little bit more of an idea of what Denny and her Denisovan dad might have looked like.
What is interesting is that these cranial fragments are quite large compared to everything else we have from Denisova. We have about 10 centimeters by 7.5 centimeters, I think, of the cranium, which, using mirroring, because we have the midline of the cranium preserved, we can actually more or less extrapolate the general shape of this cranium.
Viola says the pieces don't look very Neanderthal-like. Neanderthals had sort of an oval-shaped head.
This didn't look like that at all. It looked much more angular, but it looked very low and very robust, which, again, is quite different from what we see in modern humans.
Working with colleagues, Viola conducted comparative studies with other fossils, including one called Kabwe from Zambia. Kabwe is one of the largest hominin skulls in the fossil record.
The Denisova fragments are larger than Kabwe by, probably almost about 10%. So it's quite a difference, which again fits with these large teeth. And, I never dared, just based on the teeth, to say that these were likely big guys. But I think now with the cranium, they were likely pretty large individuals. I hope that one day we'll find more postcranial remains that will allow us to tell this much more in detail.
So for now, we still don't know much about what they looked like. But we know that Denisovans didn't stay in that cave, and that they didn't only mate with Neanderthals. They also met up and had sex with Homo sapiens, far from Siberia.
So the fascinating thing with Denisovan DNA is that, and it was again one of these things, it was unbelievable when I first heard, that this population exists. But then the next one was that Johannes Krause, who was working on this, came up to my office. By this time, I was at the Max Planck, and he said, we found a population that actually carries Denisovan DNA. And I was thinking, it's probably like in Mongolia or in China. And then he said, it's in New Britain, which is an island off the coast of Papua New Guinea. It's like, this can't be right. You guys screwed up something. I mean, this is 10,000 kilometers away. But no, that was the first population. And even today, we know, the highest amount of Denisovan ancestry we see in Australian Aborigines, Papuas in Papua New Guinea. And there's actually also some hunter-gatherer groups in the Philippines that carry quite a bit of Denisovan ancestry.
All people alive today, outside of Africa, carry roughly 1.5% to 2% Neanderthal DNA. Scientists have found that some people in Papua New Guinea carry maybe even up to 5% Denisovan DNA.
I would say a significant portion of their genome comes from these archaic hominins. And what is interesting is, up until now, we still only know Denisovans from Denisova Cave in Siberia. But the people that carry the most Denisovan DNA are down in Southeast Asia and Melanesia.
Scientists think Denisovans were likely widespread in Asia due to these patterns of Denisovan DNA in present-day humans. There's Denisovan DNA in all East Asian populations, and it's found in Southeast Asian populations too. There were also intriguing clues that Denisovans had lived in Tibet at high altitudes, much higher than Denisova Cave. There's a gene variant that modern Tibetans carry, which is different from everybody else in the world. It's a gene related to adaptation for living at high altitude, which allows Tibetan people to live and thrive on the high, cold Tibetan plateau at altitudes greater than 13,000 feet. A study published in 2014 by Emilia Huerta Sanchez links that gene to the Denisovans. Viola says it's almost identical to the one found in fossils of the ancient Denisovans from Denisova Cave. That's even though the cave sits at an elevation of only roughly 2,500 feet above sea level.
Which is just so amazing, because we know that the women who carry this Denisovan-like variant have babies with a much larger birth weight. And birth weight is one of the prime predictors of infant survival. Small babies are much less likely to survive, especially if you don't have good medical care. And so this has been selected for really, really strongly. In general, in Asian populations carry about 0.1% Denisovan ancestry. So only 1,000th of their genome comes from Denisovans. But in this one place, in this gene, in Tibetans, 80% of Tibetans carry the Denisovan allele. So it's been selected for extremely strongly. And what is funny is that this gene has been known before, but people didn't realize it came from Denisovans. It was like the best example. It was always said, this is the strongest selection pressure in humans, is this altitude adaptation in Tibetans. And it's actually, of course, it's an adaptation, but it's not that they adapted directly. They picked up this gene from the Denisovans.
This was kind of puzzling because Tibet is more than 1,200 miles from Denisova Cave, where the only fossil evidence of Denisovans had been found. Until just a few months ago, when another incredible discovery was announced.
Jaw was discovered by a team led by Fahu Chen, Zhang Zhang, Jean-Jacques Hublin, and Frido Welker in Tibet, pretty far from Siberia. The fascinating thing is this jaw was actually found in the 1980s by a Buddhist monk who went to pray in this cave and more or less sat on the jaw and picked it up, brought it back to his monastery, and it did get absolutely no attention up until about 2 years ago, when this team started more detailed investigations. They did some excavating in the cave, and they also did a relatively detailed morphological study of the jaw.
They weren't able to get DNA from the jaw, but thanks to a technique developed in part with funding from the Leakey Foundation, they managed to extract some proteins from the collagen in the bone, and they found that the jaw seemed to be from a Denisovan.
It's pretty robust with very large teeth, so it fits this general Denisovan morphotype of large, funky teeth, and a very big head, as we know from the cranial fragments we have from Denisova Cave. But I wouldn't peg a facial reconstruction on this jaw. I think that would be little premature.
So there's much more to learn about our enigmatic Denisovan cousins. What did they look like? How did they live? For how long and where? Did they make any of the tools and artifacts in Denisova Cave? How did they migrate across the planet? What was it like when they met other hominins along the way? I asked Bence Viola if he could go back in time to Denisova Cave. What would he like to see? He reminded me that I asked him the same question a few years ago at a symposium in Cleveland.
I very much hope you destroyed that, because my answer at the time was I would go back to Denisova Cave, hit a Denisovan over the head, and I'd hide him somewhere where I can find him because I want to have a skeleton. But maybe no. I would just like to go and see them, and I'd love to know how these interactions between Neanderthals and Denisovans, and Neanderthals and modern humans, and Denisovans and modern humans happened. I'm really fascinated by this question, like how did they perceive each other? Did they notice that this is somebody who's a different group? Did they just think, the guys over the hill who are kind of ugly? Or did they just interact completely normally? I think it would be fascinating to really see that, go and be there when Danny's parents met, kind of peep in on their first date, kind of thing. It would be fascinating. I don't think it's possible, but I'd love to know how these interactions happened.
Because it's clear these interactions did happen, frequently enough so that the Denisovans live on in us today, a mystery in our very genes, part of the story of where we all come from, and part of the evolutionary explanation for the way we are today, including our behavior, our bodies, and our health. Along with the trait for high-altitude adaptation that came from the Denisovans, there are genes related to our immune response, pigmentation, our ability to digest certain kinds of fatty acids, which scientists say come from our archaic relatives, the Denisovans and the Neanderthals.
Our past really strongly impacts our present as well. And I think, yes, you could say, but it doesn't really matter why. There's, for example, one of the genes linked to diabetes is also supposedly comes from Neanderthals. And you could say, why does it matter for the person who has diabetes whether this came from Neanderthals or not? You could blame Neanderthals for it, but that's not very productive. We should much more worry about, how we can solve this problem. But I think that understanding the evolutionary origins of these issues is definitely also helpful for solving them.
And so work continues today. Many teams of researchers are working to uncover more about the Denisovans, collaborating with Russian scientists who've been working for decades in Denisova Cave. It's clear that there's still much more of our story to be found there.
The main chamber is excavated. I'd say maybe a quarter of it is excavated, so there's lots of stuff to do there. And the south gallery, which is where this cranial fragment comes from and the first beautiful Denisovan molar come from, that is barely excavated. They did 2 square meters, and there's probably 20, 30 times as much left to do there. So my colleagues are focusing on that at the moment and seem to be quite successful. So I'm waiting every day. It's what usually happens, if they find something, they take a picture of their mobile phone and send it to me. And they're like, is this human? Like, hard to tell. It's a very little piece and it's a very bad photo taken with your mobile. But still, it's very exciting. Waking up in the morning and having, maybe it's another Neanderthal or Denisovan on my phone.
And it's likely that thanks to new methods, we'll find other secret histories in other tiny bones, just waiting to be discovered.
I think probably the most important message of the Denisova story is that no fossil is unimportant. Even the tiniest fragment that seems completely useless, like a fragment of a finger bone, can open up a completely new world of human evolution to us.
Thanks to Bence Viola and Viviane Slon for sharing their work. There's a link in your show notes to more information about them and their research. Dr. Viola also wants to give a shout out to his colleagues, including Anatoly Derevyanko, who for over more than 40 years has excavated countless sites in Siberia, Mongolia, Uzbekistan, and Kazakhstan, and Michael Sunkov, who now heads the excavations at Denisova. I also want to thank Sergey Zelensky, who provided the sounds of Denisova Cave and the recording of the conference there. You can learn more about Leakey Foundation grantee Frida Valker's work on ancient proteins on our blog. Origin Stories is a project of the Leakey Foundation, a nonprofit dedicated to funding human origins research and sharing discoveries. You can help fund this podcast and the science we talk about by donating to the Leakey Foundation today. On December 3rd, the Leakey Foundation is participating in Giving Tuesday, a global day of giving to the causes you care about. We're trying to raise $25,000 to support science and science education, and you can help. What's more, thanks to Gianni Amato and Gordon and Ann Getty, the first $5,000 in donations will be quadruple matched. So your $5 becomes $20, your $10 becomes $40, and if you gave $25, it would become $100. Once we pass $5,000, all donations will still be doubled. Donate now at leakeyfoundation.org/givingtuesday. That's LEAKEY foundation.org/givingtuesday. If you can't donate right now, that's okay. You can help us by rating and reviewing our show on Apple Podcasts. Tell a friend, tweet about the show. All of that helps people find us, and it means a lot. This season of Origin Stories was made possible by support from Dixon Long, Diana McSherry, Jeannie Newman, Camilla Smith, and donors like you. This episode was produced by me, Meredith Johnson. Our editor is Julia Barton. Our theme music is by Henry Nagel. Additional music in this episode comes from Blue Dot Sessions and Lee Rosevere. We'll be back next month with a brand new episode. Thanks for listening.